Christmas. There's nothing going on in our valley today. The factories are all shut down. We have the nice Christmas trees on the hills, the cows out there doing his little thing, eating grass. The sun rises, the sun sets. There's not a lot of pollution. And in fact, indeed, Christmas is one of the cleanest times of year in Oklahoma. But eventually somebody's going to come back from Christmas break back there, and we're going to start emitting some pollution here. It might take a few minutes because these oh, boy, can we see, yes. And where is all that pollution going? Remember, it is cold during the winter. A little bit of it is gets shot out, okay, but a lot of it gets trapped in that valley. Now this one over here, in this particular case, our factory is on the top of a hill, and it shoots its pollution higher into the atmosphere. That can be a dispersion technique, not always all that effective. But now, how are we going to get rid of this pollution here? Well, certain weather systems come along. We'll say that it gets bright and sunny. That doesn't do much. This is winter. That's pollution just keeps building back there. Oh, time for the sun to set. Not much is happening. So one way we can actually get rid of this pollution is fairly simple. Let's say that there's a big storm. Actually kick up some big turbulence, maybe a thunderstorm during the summer. Well, this isn't, or some just big winter storm with a whole lot of wind during the winter. Now sometimes it's just not strong enough, and the pollution settles back into the bottom of the valley, and we get stuck again. So let's try a bigger storm. Let's see, can we see now? Yes, we can see clearly. And when we change our wind direction, say southwesterly wind, it picks up some dust maybe, but it really kicks the pollution out of here. But that pollution goes somewhere. So if you're downwind, it can be a problem. And Oklahoma, we usually are downwind, or we're long-range transport dominated. It comes from somewhere else, right? But eventually the storm ends, and guess what? The pollution begins to rebuild in the valley again. Of course, now it's the weekend, so the factory isn't working, but oh, there it comes again. It's Monday morning, and choo 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 choo, here we go. And that's pretty much our microcosm here. Usually we have people ask questions. Does anybody have any questions?
How does the sun affect your pollution?
How does the sun affect your pollution? Well, during the winter, the sun usually doesn't do much. It might heat up the bottom there, but because of all the fog and soot, very little of the sunshine actually gets to the bottom of the valley. So that leads to very little vertical mixing based on sunshine, and at night, the pollution again settles back into the bottom of the valley. So, and this will happen in urban areas too when it's calm. Usually in Oklahoma, we don't have this much of a problem because we're not stuck in a valley like this. But if you're Dallas, it's a big city, so it may well act that way if the wind is calm. Or Oklahoma City can do that sometimes too. Tulsa can do it too. Anywhere theoretically could do it if the conditions are right. But now during the summer, the sun generates, and really during the winter too, but during the summer we get about 3 times as much sunshine as we do during the winter, all told. But during the summer we generate photochemical pollution, named most notably ozone. So the sun actually contributes to our pollution problem. During the summer. During the winter, we generate ozone, but the sun generates ozone, but the sun period is so short, and it's so weak that it's not that much of a concern. Go to Ciudad Mexico, however, for example, and December and January are their sunniest months of the year. June, July, and August are cloudy and stormy, and they're least sunny months of the year. So they have a lot of their ozone pollution episodes during what we would consider the winter, or actually what they would consider the winter too. It can be quite cold there. Any more?
What causes the pollution to settle downwards towards the ground instead of going up into the air?
Good question. Good question. And what that's usually called is a thermal inversion. Usually, when the surface of our valley here is very hot compared to the mountaintops, or to the air above it, we have deep vertical mixing because there's no thermal inversion. Temperatures are cold aloft; they're warm at the surface. So that in order to maintain that requires deep vertical mixing, which can be generated by sunlight, or sometimes storms can generate that vertical mixing. During periods of thermal inversions, however, the temperature is actually warmest above the top of that cloud layer that we had earlier on our microcosm, and it's colder down in the valley. This happens usually at night. We get this kind of a condition, and usually during the daytime in Oklahoma, we have strong enough sunshine that we mix out that inversion by heating the ground layer. Sometimes when we have a thick layer of clouds or pollution, not enough sunshine gets through to the bottom, and we don't heat up the ground layer, and the inversion persists for day after day after day. This is more common during the winter, obviously, because the sun is much, or the sunshine that we get much less incoming solar radiation during the winter months.